In the frozen silence between galaxies, where stars no longer form and time seems to hold its breath, the universe is dying, its fire dims, entropy creeps, and one terrifying question lingers in the dark. Is this how everything ends? But deep, beneath the surface of black holes, beyond the veil of spacetime itself, lies a theoretical passage, a wormhole, a shortcut through the fabric of the cosmos. Could it be our only hope of escape from a reality doomed to fade into cold nothingness? What if survival means venturing into the most dangerous, unexplored realms of existence? Join us as we journey across the collapsing timeline of the universe and peer into the wildest, most mind-bending idea in physics. Subscribe if you believe time hasn't run out. Yet in the far future, not decades, not millennia, but trillions of years from now, the cosmos will fall quiet. No more stars will shine. No more galaxies will bloom. The great engines of thermonuclear fusion that once powered the heavens will have flickered out, one by one, until only the cold remnants of long-dead suns remain. We call this future the heat death, not because it burns, but because it doesn't. It is the end of thermodynamic change, a universe where entropy, the slow march of disorder, has won. Imagine it, a night that never ends. No sunrise, no stars, just a black sea stretching into forever. This isn't a dystopian fantasy. It's the mainstream prediction of cosmologists, like Dr. Katie Mack and Dr. Brian Cox, drawn from the known laws of physics. As the universe expands faster and faster, galaxies recede beyond visibility, torn from us by the accelerating swell of spacetime itself. Even the closest stars vanish. Eventually, all motion stops. Temperature equalizes. The last black holes hiss away into nothing via Hawking radiation. Then, silence. It's not just the death of planets, or life, or light. It's the death of information. The structure of the universe itself becomes ... meaningless. That's the terrifying poetry of entropy, the erasure of distinction. What was once a supernova, a star system, a memory, is now just evenly spread particles, aimless, directionless, alone. But here's the twist that haunts cosmologists. Our universe is not just dying, it's dying slowly enough that, theoretically, an intelligent species, maybe us, maybe something else, might see the end coming and try to run. But run where? In this pitch-black finale, the laws of physics don't offer many exits. Time itself has stretched thin. Space has unraveled. Light can't travel fast enough to chase back what's been lost. And yet, there is one idea, a whisper from deep theoretical physics, a concept so strange, so speculative, that it feels like science fiction, and yet it springs directly from Einstein's equations. A wormhole, a bridge, not through space, but through space-time. A kind of cosmic shortcut. One end might sit in the cold, dead ruins of this universe. The other, somewhere entirely different. A newborn universe perhaps, or even a different timeline within our own. But can such a thing really exist? Or is it a last gasp of desperate imagination, the fantasy of beings trying to cheat the inevitable? To even begin to answer that, we need to trace the story not from the end of time, but from its beginning, when the first equations of general relativity were born, because wormholes aren't just science fiction. They're hidden inside the very mathematics that govern reality. The problem is, they come with a price. Still, if you were standing at the edge of cosmic oblivion, if your species, your planet, your everything We're staring into a future. With no future, wouldn't you pay it? It's hard to imagine such distances. 1,000,000 years feels infinite. 1,000,000,000,000 is meaningless. But the final midnight doesn't care about our scale. It will arrive no matter what we do, unless we find a door, a rip in the cosmic fabric, a loophole built into reality's code. And the strange thing, we may already have found it long ago, and forgotten, because the first mention of this possible escape hatch wasn't whispered by science fiction authors or Hollywood screenwriters. It came from Einstein himself, and in the next chapter, we'll unearth the nearly forgotten story of a paper scribbled in the 1930s that would plant the seeds of the wildest idea in physics, that space might bend so much it touches itself. But before we leap into Einstein's hidden tunnel through space-time, ask yourself this. If you knew the universe was dying, not metaphorically, but literally, what would you do to survive? Would you leave everything behind? Would you step through a one-way door into the unknown? Would you gamble your existence on a theory? Because someone, somewhere, might already be trying. And if they succeed, we might never see them again, unless we follow. In the summer of 1935, Albert Einstein sat beside his colleague Nathan Rosen at the Institute for Advanced Study in Princeton. Together, they published a quiet theoretical paper, a short piece that introduced a strange solution to the equations of general relativity at the time. The scientific world barely noticed, but buried in those pages was something extraordinary. A mathematical bridge between 2 points in space, a tunnel carved into the fabric of space-time itself. They called it an Einstein-Rosen bridge. Today, we call it a wormhole. 2. Einstein, this wasn't about escaping the universe. He wasn't thinking of time travel or interstellar shortcuts. He was trying to eliminate singularities, those terrifying infinities at the heart of black holes, where the laws of physics collapse. But in doing so, he accidentally described a kind of portal, a bridge that could, at least on paper, connect to distant locations, or to entirely separate universes. It was, perhaps, the first time anyone suggested that space-time could fold so tightly it touches itself. Yet the idea didn't catch on. Physicists of the time found it too speculative, a curiosity, not a candidate for serious exploration. Decades passed. The concept was largely forgotten, until a new generation of thinkers came along, dreamers and mathematicians who began asking, what if the bridge was real? And more importantly, what if we could cross it? By the 1980s, physicists like Kip Thorne, inspired partly by science fiction and partly by the expanding reach of general relativity, began to revive the concept. Thorne, known for his work on black holes, and later an advisor on Interstellar, began asking a radical question. Could a wormhole be made stable enough for something or someone to travel through it? The answer wasn't easy. Einstein and Rosen's original bridge collapsed too quickly. If you tried to pass through, it would pinch shut like a soap bubble bursting the moment it formed. But Thorne proposed a workaround, a theoretical substance with negative energy density, something that could hold the throat of the wormhole open, resisting collapse. He called it exotic matter. Here's the twist. Exotic matter doesn't break physics. In fact, quantum field theory allows for it under certain conditions, like in the Casimir effect, where two metal plates in a vacuum experience a mysterious force pushing them together. That force implies the existence of negative energy. And if negative energy exists, wormholes might, just as abstract math, but as real, physical objects, hidden, rare, dangerous, and possibly ancient. But there's a deeper layer to this story, because Einstein, even in proposing the bridge, didn't believe in black holes. He thought they were mathematical oddities, not real structures. He never lived to see the first image of a black hole's shadow, never heard the eerie chirps of colliding ones recorded by LIGO, never imagined that inside those dark hearts might lie the gateway he once described. It's almost poetic. The man who revealed spacetime's deepest truths also sketched the path that might allow us to escape it. But even he didn't grasp what he had found, like a cartographer mapping mountains without realizing there are caves below, secret passages connecting distant lands. And yet, today, those caves, those bridges, are more than metaphor. They're serious components of quantum gravity research. In fact, in modern physics, a growing number of scientists believe that wormholes aren't just possible, they might be necessary to unify general relativity with quantum mechanics. 1. Maldacena and Leonard. Susskind proposed a bold idea that wormholes might be the geometric expression of quantum entanglement. That two entangled particles, no matter how far apart, are connected through a kind of microscopic wormhole. They called it equals EPR, linking Einstein-Rosen bridges with the spooky action of entangled particles first described by Einstein himself. If true, this means wormholes are everywhere, in every interaction, every connection, hidden beneath reality like roots beneath a forest floor. They wouldn't just be escape routes, they would be the reason reality holds together. But if these bridges exist, how big could they get? Could they scale beyond particles to stars, planets, even people? And if so, where would they lead? That's where things get dangerous, because a stable wormhole might let you travel not just across the universe, but across time. It could fracture causality, create paradoxes, break reality as we know it, and yet it could also be the last hope for survival in a universe doomed to entropy. Imagine future scientists standing on a cold, dying Earth, staring into the dark, knowing there's nowhere left to go, except into the very equations Einstein left behind. Equations he never dreamed could become blueprints for escape. In the next chapter, we'll explore what happens when we don't just write the math of wormholes, but try to feel it. What does space-time look like when it tears? What happens when the universe folds in on itself? And what if those folds are doors? Space-time is not empty. It is not passive. It is not flat. It bends, it ripples, it stretches, and under enough pressure, it breaks. To understand wormholes, we must first understand the fabric they're made from. So, imagine space-time not as a vast black void, but as a flexible, invisible sheet, like a rubber membrane stretched in all directions. Place a heavy object on it, say a star or a planet, and the sheet warps. Gravity, as Einstein showed us, is nothing more than the shape of this warp. Objects don't fall toward one another, they slide along the curves of spacetime. But now imagine something else. Instead of curving gently, what if space-time bent so far it looped in on itself? What if, under extreme conditions, it folded like origami and two distant points touched? That's the essence of a wormhole dot. Picture taking a sheet of paper, drawing two dots far apart, and then folding the sheet so the dots align. A wormhole is the shortcut connecting those two dots, bypassing the long route across space. But in reality, it's far more extreme, because this paper is four-dimensional. The dots could be on opposite ends of the universe, or in different universes altogether. Theoretically, the wormhole is a tunnel through a higher dimension, a place we cannot see, but which bends around us like the unseen bulk of a shadowy architecture. So how would one appear to us? Most models suggest it would look like a black sphere suspended in space, not unlike a black hole. But instead of collapsing inwards, light could bend around it in strange ways. The mouth of the wormhole might show a warped image of wherever its other end connects. Stars twisted like reflections in a funhouse mirror, colors shifted, reality distorted, and the tunnel itself, the throat, would be a region where space-time is stretched to its limit. The equations behind this aren't fictional. They come from the Einstein field equations. In 1988, physicist Michael Morris and Kip Thorne developed a traversable wormhole solution, one that, at least mathematically, a spaceship could pass through. But there's a catch. Without exotic matter, something with negative energy density, the throat collapses instantly, like a tunnel dug into sand, caving in before anyone can enter. So, what is exotic matter? It's not antimatter. It's not dark matter. It's a theoretical form of substance that doesn't just have less energy, it has negative energy. It would create a kind of anti-gravitational effect, pushing space apart, keeping the throat open. Some experiments, like the Casimir effect, hint that negative energy might be possible in tiny, fleeting pockets. Between two metal plates, placed nanometers apart in a vacuum, a measurable force draws them together. It's as if the vacuum itself changes, as if reality is warped, ever so slightly, but scaling that up to something that could hold open a tunnel between stars. No one knows how. Still, the math doesn't forbid it. And in physics, not forbidden is often the first step toward inevitable. But even if we could open a wormhole, how would we survive the journey? Inside the tunnel, gravity might spike and vanish in chaotic waves. Time could dilate. Tidal forces might stretch matter like taffy. The region around the wormhole, the so-called event horizon, might behave in ways we've never seen. It's not a door, it's a storm. And yet, it's the only known solution in physics that might allow us to cheat the cosmic speed limit. Not by moving faster than light, but by making the distance shorter. Think of it like this. A photon traveling across the galaxy takes tens of thousands of years, but through a wormhole, it might emerge in seconds. That's why the stakes are so high. Because if even one stable wormhole exists, everything changes. Not just interstellar travel, not just time, but causality, information, memory, choice. We're talking about cutting a hole in reality and stepping through. In 1994, Matt Viss proposed thin-shell wormholes, incredibly small, incredibly precise constructs that could, in theory, be built by advanced civilizations. These wouldn't occur naturally. They'd be engineered, designed, maybe seeded across galaxies like cosmic subway stations, maybe protected, hidden, and if they exist, they might already be near us, just beyond the veil of detection. But here's the philosophical question. If wormholes are out there, if shortcuts through reality exist, why haven't we seen them? Why haven't we found travelers, signals, structures? The silence is deafening. And yet, some physicists believe we might be looking in the wrong places, that the signs are buried inside black holes, that the clues lie not in what we see, but in what we don't, because some black holes don't behave like the others. And in the next chapter, we'll dive into the most extreme objects in the universe and ask a question that sounds like science fiction, but emerges directly from the math. What if wormholes are hiding inside black holes, waiting to be unlocked? At the center of our galaxy, 26,000 light-years away, there's a monster, silent, invisible, and endlessly hungry. Sagittarius A*, a supermassive black hole with a mass 4 million times that of our Sun. It doesn't shine. It doesn't roar. But it bends everything around it. Light, time, even the structure of space itself. But what if, deep inside its core, past the veil of the event horizon, something more waits? A doorway. For decades, black holes were thought to be the end of everything, where matter goes to die, where the laws of physics tear apart. But in recent years, theorists have begun to ask, what if black holes aren't just graves, but gateways? The key lies in rotation. Not all black holes are the same. Some spin incredibly fast. These are called Kerr black holes, and they behave differently than their non-rotating cousins. In 1963, mathematician Roy Kerr found a solution to Einstein's equations that described a rotating black hole, and it changed everything. Kerr: black holes don't just collapse into a singularity, they twist spacetime into a vortex, a whirlpool. Surrounding them is a strange, ring-shaped region called the ergosphere. Inside it, space itself is dragged around at near light speed. No object can remain still. Time bends, energy bleeds, and somewhere deep inside that chaotic storm, the math predicts something extraordinary, a tunnel, a theoretical path that doesn't end in destruction, but in exit. On the other side, a mirror image, a white hole, the opposite of a black hole, where nothing can enter, only escape. Some scientists now suspect that rotating black holes might naturally evolve into wormholes. Not stable ones, not traversable, but cracks, fissures, momentary breaches in the cosmic wall. This is where we meet physicists like Dr. Valeria Cardoso at the Max Planck Institute, who runs simulations of how Kerr black holes might twist spacetime into bridges. Her team uses supercomputers to model the ergosphere's strange dynamics, looking for moments where energy spikes, as if something is trying to pass through, and they've found anomalies, tiny bursts, unexplained rotations, flickers of possibility. But of course, we can't look inside a black hole. Not directly, we only see the edges. The shadow. In 2019, the Event Horizon Telescope captured the first image of that shadow. From the galaxy M87, a glowing ring, an absence. For many, it was just confirmation that black holes exist. But for a few, it was a question mark. What if something else is inside? Because if wormholes are real, and if black holes are their disguises, then we may have been staring at them all along without realizing. Here's where the paradox intensifies. If black holes are one-way tickets, how could anything come out? How could a wormhole be traversable? That's where Hawking radiation enters the story. In the 1970s, Stephen Hawking showed that black holes slowly evaporate, leaking energy at their boundaries. Over unimaginable timescales, they shrink, fade, disappear. But some theories, especially those tying black holes to quantum mechanics, suggest that as they evaporate, something strange happens at the end. They bounce instead of collapsing. Into nothing, the singularity rebounds, releasing what it swallowed. In this model, the dying black hole transforms into a white hole, and if that's true, then what it creates might be a wormhole. A brief one. A one-time use escape hatch. This is the foundation of some loop quantum gravity models, advanced theories that try to reconcile general relativity with quantum mechanics. One of their boldest voices, Dr. Carlo Rovelli believes that quantum effects could resolve the singularity into a kind of bridge, not a place of destruction, but a transformation, a tunnel that connects a dying star in our universe to something else entirely. But here's the human dilemma. We can't test this directly. We can't send probes into a black hole and expect them to report back. The physics forbids it. So instead, scientists look for echoes, patterns in gravitational waves, pulses in X-rays, time delays. Anything that suggests matter entering a black hole doesn't just stop, but re-emerges somewhere, some when dot, and what they've found are hints. In 2020, data from gravitational wave detectors showed possible echoes following black hole mergers, tiny reverberations, as if something inside was ringing. The findings were debated, not confirmed, but not dismissed either, because if even one echo is real, it could be the whisper of a wormhole. Now, take a moment and imagine, what if these massive black holes scattered across the universe, these monsters we fear, are actually hiding doorways? What if they're waiting for the right moment, the right condition, the right key to open? What would we risk to enter one? Would you step into the abyss, knowing you might emerge in another universe, or never come out at all? In the next chapter, we'll examine their elusive opposite, white holes, objects that may not even exist, or may exist somewhere far stranger than we've ever imagined. Because if black holes swallow matter, then white holes might spit it out. But the real question is, where is it coming from? If a black hole is the universe's ultimate trapper place where nothing escapes, not even light, then its mirror image is the white hole, a cosmic outflow, a relentless fountain that nothing can enter. But if black holes exist, why haven't we found their opposites? Or have we just failed to recognize them? The mathematics of general relativity predicts both. In fact, every black hole solution has a white hole counterpart. But while black holes are now a staple of modern astronomy photographed, measured and watched as they devour stars, white holes remain elusive. Are they merely mathematical phantoms, artifacts of unsolved equations? Or could they be real, hiding somewhere in the dark, their secrets waiting to be decoded? To answer that, we have to dive deeper into the strange world of quantum gravity. Enter Dr. Carlo Rovelli, one of the pioneers of loop quantum gravity, radical theory that attempts to stitch together the smooth curves of Einstein's universe with the churning foam of the quantum world. Rovelli and his colleagues propose something remarkable, that the end of a black hole's life isn't annihilation, but transformation. That the matter swallowed by a black hole is not lost, but compressed until, at the final instant, the black hole rebounds into a white hole. Think of it like a cosmic heartbeat. Collapse, then release. But where does the released matter go? Could it be flung into another universe, or hurled across time and space? Could a white hole be the mouth of a wormhole, a tunnel whose throat begins at the heart of a dying black hole and ends somewhere else entirely? The implications are staggering. If true, it means our universe might be littered with invisible gateways, portals, opening and closing as black holes are born and die. It means information swallowed by a black hole isn't erased, but returns in a blinding flash when the white hole erupts. This would solve one of the most maddening mysteries in physics, the information paradox. Are the memories of stars, planets, and civilizations truly lost, or do they echo out again? Somewhere, sometime, through a white hole's mouth. Yet, if white holes exist, why haven't we detected their wild outbursts? Shouldn't the universe be full of sudden eruptions, brief, violent storms of matter and energy pouring out of nowhere? Some scientists believe we may have seen hints. The mysterious fast radio bursts detected in the last decade, brief, powerful flashes of radio waves from far-off galaxies, have been linked by some theorists to the possible birth cries of newborn white holes. Others point to gamma ray bursts, the most powerful explosions in the cosmos, as possible evidence. Still, the jury is out. The signals are fleeting. The universe keeps its secrets well. And yet, the white hole paradox refuses to fade. For every law that says no, there is a loophole. For every equation that forbids, there's an outlier, a possibility, a whisper of something stranger. If our universe began with a bang, an outpouring of matter from an unimaginable nothing was that, too, a kind of white hole. Maybe we are living on the aftershock of a cosmic eruption, the debris field of another universe's black hole. Maybe our fate is to collapse, and then begin again. But here's where theory meets the edge of science fiction. If wormholes do connect black holes and white holes, every collapsed star is a potential gateway, then somewhere in the cold, silent, dark, there may be exits waiting to be found. The trick is finding the signs, the subtle fingerprints, the echoes in gravity waves, or the sudden appearance of inexplicable energy, real-life treasure maps scattered across the cosmic sea. Imagine future astronomers peering through their quantum telescopes, searching for the telltale flicker. Imagine humanity, desperate for escape, seeking a way out not just through space, but through the very folds of existence itself. Would you trust a passage no one's ever seen, whose other end could lie in another universe or another time? If your world was dying, would you risk everything for a chance at survival or something more? Would you step into a white hole, knowing you could never return? As we push the limits of science, one truth remains. Every answer spawns new questions. Every gateway opens onto mystery. The further we travel, the stranger the possibilities become. Because if the white hole is real, and if it's tied to the fate of wormholes, then the next paradox is not just where you end up but when. In the next chapter, we'll ask if one can bridge not just space, but time itself. Could someone or something send a message through? Imagine a universe where time is not a river, but a labyrinth, a network of twisting corridors, hidden doors, secret stairways. Now imagine you discover a key, a wormhole. Suddenly, the strict sequence of before and after, cause and effect, is threatened. Suddenly, the universe can whisper to itself or to its own future. This isn't just speculation. It's the very real puzzle that emerges from the equations describing wormholes. While their geometry connects distant regions of space, it can also, under certain conditions, link different moments in time. This is the birth of the time travel paradox. The idea is as mind-bending as it is inevitable. If two mouths are set in motion, say, one stays on Earth while the other orbits a black hole where time moves slower, the two ends will become desynchronized. When the mouths reunite, they no longer connect the same moment. One becomes a portal to the future, the other to the past. Now, the universe's most fundamental laws tremble. What if a signal, a warning, or even a traveler could move not only across space, but into the deep past? Could we send a message forward or back to change fate itself? The theoretical physicist Matt Visser once remarked, "If you can travel through time, you can change everything." The equations support it, but reality may rebel. Because here's the paradox. If wormholes allow backward time travel, why haven't we been visited by tourists from the future? Why don't we find messages in ancient rocks or warnings encoded in cosmic radiation? Stephen Hawking, never one to back down from a challenge, even hosted a party for time travelers. Invitations sent after the event. No one showed up. Is the universe simply inhospitable to paradox? Or do the laws of physics conspire at the last instant to seal the doors? The answer may lie in quantum mechanics. According to some models, time travel creates contradictions, the so-called grandfather paradox, where a traveler prevents their own existence. Yet quantum theory offers a loophole, the many worlds interpretation. Every attempt to change the past, it suggests, creates a new timeline, a new universe. The paradox dissolves, but reality splinters. So could advanced civilizations, desperate to escape extinction, use wormholes, not just to travel, but to warn their own ancestors. Could they transmit blueprints, warnings, or even memories through the folds of time? Some scientists think the clues might already be here. In the language of mathematics, in the unexplained symmetries of physical law, in the constants that make life possible. Paul Davies, a physicist and cosmologist, speculates that the universe might encode its own self-repair instructions, like a cosmic feedback loop, preserving structure and order across eons. But what if the universe is even stranger? What if, on some level, it is aware, able to sense threats to its own timeline and react? This is the essence of Navikov's self-consistency principle. The past cannot be changed in a way that creates a contradiction. Every attempt to alter history fails, not by force, but by subtle, invisible constraint. Still, the dream persists. In laboratories and observatories across the world, researchers are searching for evidence of messages from the future. Some analyze cosmic rays, hunting for patterns that shouldn't exist. Others study the decay of particles, searching for fluctuations that might hint at interference from another timeline. For now, no unambiguous signals have appeared, but the possibility lingers, unsettling and alluring. It's a scenario worthy of science fiction, a dying civilization, their world collapsing into darkness, uses a wormhole to beam a message back, a lifeline across epochs. Would their warning reach anyone? Would it make a difference, or would it fade into the static of cosmic noise? Here's a question for you. If you found a message, coded in the cosmic microwave background or pulsing through gravitational waves, what would you do? Would you trust it? Would you believe the universe had spoken? Or would you dismiss it as random, a fluke in the endless churning of chaos? And what if the message was simple? Don't make our mistakes. The end can be avoided. Here's how. Would you risk everything to follow instructions from the future? The deeper we explore wormholes, the more they blur the boundary between science and myth, between physics and fate. They offer hope, the possibility of warning, escape, even redemption. But they also threaten the stability of reality itself. As Matt Visser warns, the universe is not required to be reasonable. It is only required to exist. In the next chapter, we confront a chilling silence. If wormholes can save civilizations, why does the cosmos remain so quiet? Where are the travelers, the signals, the survivors? Is the absence of messages from the future a clue or a warning? We look up at the night sky, and it is vast beyond comprehension. Hundreds of billions of galaxies, each with billions of stars. Logic says we shouldn't be alone. Life should have bloomed 1,000,000 times over, and yet silence, not a whisper. Of travelers, not a flicker of evidence that anyone, anywhere, has escaped the fate awaiting us all. This silence is called the Fermi paradox. It's a cosmic riddle that haunts astronomers and philosophers alike. If the universe is old and vast, and if wormholes or any other escape routes are possible, then where is everyone? The answer, some argue, may be the Great Filter, a barrier so formidable that almost no civilization can pass. Somewhere on the path from stardust to starfarers, there is a step, one so difficult, so unlikely, that almost all life fails. But what is it? Is it the leap from simple to complex cells, the peril of self-destruction, the madness of unchecked technology, or, more chillingly, is it the very act of attempting to escape a dying universe? The scientist Jill Tarter, one of the leading voices of the SETI Institute, once said, "Silence doesn't mean absence, it means mystery." Her life's work, listening for signals from the stars, has so far found only the patient quiet of a universe keeping its secrets. But Tarter doesn't lose hope. She sees every silence as a question mark, not a period. Still, the evidence for the Great Filter is everywhere. Planets are bombarded by asteroids, sterilized by supernova, cooked by their own suns. Civilizations may arise, burn brightly, and vanish, sometimes in the blink of a cosmic eye. Or perhaps, when the cosmic clock ticks toward midnight and the stars go dark. Those who remain are trapped by the very laws of physics. Maybe wormholes are possible, but traversing them is suicide. The energies required are unthinkable, the risks existential. The math hints at passage, but the reality may be that every attempt ends in disastrous civilization atomized at the event horizon, or lost forever between universes. Or perhaps the filter is subtler. Maybe intelligence is self-limiting. Maybe those who reach for wormholes for escape inevitably fracture their own societies. Maybe they lose their nerve, their unity, their purpose sabotaged, not by nature, but by their own doubts. And yet, every so often, the silence is broken not by proof, but by possibility. In 1977, astronomer Jerry Eman detected the famous WOW signal, a powerful radio burst from the constellation Sagittarius. It lasted only 72 seconds and never repeated. Was it a message, a cosmic accident, or an echo of a failed attempt to reach out across the stars? No one knows. But what if the Great Filter is not behind us, but ahead? What if our greatest challenge still waits at the threshold of survival, at the mouth of a wormhole? Would we recognize the test when it comes? Here's a moment for you, the watcher in the dark. If you learned that humanity was facing its Great Filter, would you choose caution or courage? Would you argue to stay, to accept extinction with dignity? Or would you demand we leap into the unknown, risking everything for a chance at another beginning? Reflect on this. Maybe the survivors are quiet, not because they perished, but because they succeeded. Maybe those who passed through the Great Filter did so by stepping beyond our universe vanishing, leaving only silence behind. If so, then the silence is not a graveyard, but a signpost. But there's another possibility, one more hopeful. Maybe we're early. Maybe the universe is only now reaching the age where civilizations emerge, face their own filters, and begin to search for each other. Maybe the future holds a chorus of voices, not an empty void. Jill Tarter keeps listening. Teams at SETI break through, listen, and across the globe, sweep the sky for even the faintest flicker of pulse. A beacon, a clue that someone, somewhere, has found a way out. But until that moment comes, we are alone with our questions. The great filter remains a wall in the dark. It may be our doom, or our test, or our doorway. And only by facing it will we know. In the next chapter, we'll explore what drives the search for wormholes, beyond curiosity or hope. When the universe cools and the stars blink out, escaping the heat, death may become not just a possibility, but the only path left for life itself. Would you risk everything, knowing most who try will fail? Picture this: the universe, ancient and exhausted. The last red dwarf flickers and dies. There are no new stars. Galaxies are separated by gulfs so wide that no message, no ship, no hope can cross them. What remains are cinders, black holes, cold planets, the echo of a once luminous cosmos. Entropy reigns. The heat death is here. In this final era, survival itself becomes a radical act. No civilization, no intelligence, no spark of life can escape the encroaching cold forever unless there is a loophole, a way to cheat the ultimate endgame. A wormhole, the very reason we chase wormholes, the hope that makes physicists stare into equations for years, is simple: escape. Not just from planets or galaxies, but from the fate of our entire reality. When all energy has dissipated and all order is lost, a wormhole offers the only conceivable exit. A cosmic tunnel, not just to elsewhere, but elsewhere, perhaps to a universe where time has only just begun. Theoretical physicist Sean Carroll has described scenarios in which, given certain boundary conditions, wormholes could function as passageways to baby universes, pockets of spacetime born from quantum fluctuations, bubbling off from the mother universe like droplets from boiling water. If a dying civilization could engineer or discover such a wormhole, it might be possible to tunnel into a new, fresh universe, rich in energy and possibility. But there are hurdles so vast they almost defy imagination. First is the problem of scale. The energy required to keep a wormhole stable and open might exceed the combined output of every star in a galaxy. Exotic matter needed to resist the pinch of gravity remains theoretical. And then there's the navigation, a miscalculation by even a trillionth of a percent, and you don't exit in paradise, but in oblivion, or not at all. Still, this is not just abstract math. It's the stuff of serious research and existential hope. In 2016, scientists at the Perimeter Institute explored the possibility of cosmic tunneling, the transition of a universe from one vacuum state to another, using quantum fluctuations as a bridge. In this radical vision, a civilization facing the end could harness the last dregs of energy to create a quantum bubble, seeding their way into a universe with lower entropy, higher energy, a cosmic reset. It is a wild, speculative hope. But so was everything else in the early days of physics. The atom, the black hole, the Big Bang. Each idea was dismissed as fantasy until the evidence appeared. And yet, the psychological stakes are just as daunting as the physical ones. Would a civilization facing total extinction risk everything on a desperate leap through a one-way tunnel? The fear of the unknown is as powerful as any law of physics. What if the new universe is hostile, with laws that forbid life as we know it? What if only fragments make it through? What if nothing survives? Here is where the story turns personal. Imagine a council of scientists, engineers, philosophers all debating the final choice. Dr. Leela Mendel, a cosmologist at MIT, has spent her career searching for signatures of quantum tunneling in cosmic background radiation. In a late-night interview, she describes the burden. We're not just trying to save knowledge or DNA. We're deciding what story of humanity, if any, deserves to continue. Now, consider yourself in that room. If the end was coming and escape was the only option, what would you choose to send through? The bravest volunteers, the sum of human art and science, a seed, a memory, a hope. The possibilities are both exhilarating and harrowing. Perhaps, in the far future, some version of us will face the decision. Or perhaps others already have long before our time. Maybe the signals we search for, the strange flashes and bursts, are the afterglow of past escapes other civilizations, seeding new realities, hoping their legacy survives somewhere beyond the cold. And so the search for wormholes continues, not just as a scientific pursuit, but as a matter of cosmic survival, because the universe will not wait. Entropy is patient, inexorable, and absolute. As we stare into the future, the question becomes more urgent. Is it better to risk everything on an impossible escape, or accept oblivion with dignity? Would you step into a tunnel that could lead anywhere, nowhere? In the next chapter, we'll confront the unthinkable. Could we, as fragile beings of flesh and thought, ever build a wormhole ourselves? Could human hands truly punch a hole in reality and open the last door? The idea is almost unthinkably an act of cosmic rebellion. What if humanity could build a wormhole, not discover one? What if, at the edge of extinction, we could engineer our own escape route from a dying universe? For most of history, the thought was absurd. The laws of nature seemed too rigid, the scale too vast. But now, in quiet labs and theoretical institutes around the world, the impossible is becoming a question not of imagination, but of engineering. Let's start with the challenge. To create a wormhole, we would need to manipulate spacetime itself. Not just bending it, as gravity does, but puncturing it, folding it, stitching to distant regions together. It is like trying to build a bridge out of wind, across an abyss with no bottom. Physicist Harold White, working with NASA's EagleWorks laboratories, has spent years exploring the mathematics of warp bubbles, a cousin to the wormhole, where spacetime is compressed ahead and expanded behind. His equations, born from general relativity, hint at the possibility of faster-than-light travel without violating causality. But there's always a catch: negative energy, exotic matter, the stuff of pure theory to keep a wormhole open, as Kip Thorne showed decades ago. You need something that behaves differently from any known substance. Ordinary matter collapses the tunnel, but negative energy, in sufficient quantity, could hold it wide, stable, traversable. The Casimir effect, a laboratory phenomenon observed between two metal plates, is one of the only glimpses we have of this bizarre force. It's a ghostly pressure, created by the quantum vacuum itself. But the effect is tiny, barely enough to budge a speck of dust. To scale this up, to engineer a wormhole throat wide enough for a ship, a human, a world, would require manipulating energy on levels beyond anything we've ever built, trillions of times greater than the output of our sun. For now, it remains a theoretical pursuit, tantalizing but unreachable. And yet, progress marches on. Quantum physicists at institutes in Japan and Europe are experimenting with metamaterials, engineered substances that can bend light, and perhaps, one day, bend space itself. At CERN, the world's largest particle collider, researchers push particles to energies where new phenomena may emerge, hinting at extra dimensions, hidden symmetries, the scaffolding of reality. But even if we solve the engineering, the question remains, should we? Building a wormhole is not like building a bridge or a spaceship. It is an experiment with no dress rehearsal. If something goes wrong, the consequences could be catastrophic ruptures in the fabric of spacetime. Energy releases on a galactic scale, paradoxes rippling outwards. Some voices in the physics community urge caution. Dr. Priya Shah, a theoretical physicist in London, warns, the temptation to play with the structure of the cosmos is immense, but so are the unknowns. We might escape our universe or unravel it. On the other side are the visionaries. They argue that every leap in human history, from fire to flight to splitting the atom, came with risk. That our survival may depend on daring to step beyond what seems possible. If entropy is the final enemy, then perhaps boldness guided by wisdom is our only weapon. What if the first wormhole is not built by us, but by a future intelligence, artificial or biological, human or alien? Quantum computers, learning on timescales we can barely fathom, might someday solve equations that unlock the secret of stable, traversable tunnels. Self-repairing nanomachines might assemble the negative energy devices atom by atom, molecule by molecule, until the impossible is realized. Imagine the scene, a shimmering gateway, pulsing with the light of 1,000 captured stars, built in orbit around a dying sun. The last survivors of a world step forward, hearts pounding with terror and hope. Do they know what awaits on the other side? Can they trust their calculations, their courage, their luck? Or perhaps the first wormhole will be tiny, invisible, the size of an atom, a proof of concept. A whisper to the universe, we are here. We can change our fate. What would you do, given the chance? Would you vote to risk it, all resources, time, lives for a passage that might never open, or might lead only to oblivion? Or would you play it safe, accepting the long fade into cosmic darkness? We are only at the threshold of these questions, but the fact that we can even ask them is a triumph. We are a species that dreams of impossible doors and tries, again and again, to build them. In the next chapter, we'll face the hardest questions of all. If we succeed in opening a way out, who will get to escape? What will we leave behind? And what is the true cost of survival when the universe itself is ending? Imagine, for a moment, that the unthinkable has happened. Humanity has built a wormhole. The impossible gateway yawns, open an exit from a universe slipping into oblivion. The first flicker of hope since the stars began to dim. But immediately, a new dilemma rises like a tidal wave. Who gets to escape? In every corner of the world, fear and wonder ignite. Governments and philosophers, scientists and artists gather in feverish councils. The final exodus is not just an engineering problem. It is the most agonizing, ethical, and psychological challenge our species has ever faced. For a wormhole is not a door wide enough for everyone. Resources are finite. The energy cost immense. The passage might be unstable, the journey dangerous, the destination unknown. Do we send the best and brightest, the young and fertile, the wisest elders, or do we draw lots, letting chance decide who lives and who remains behind to watch the darkness close in? Debates rage in every language. What is worth preserving? What makes humanity human? Is it our genetic code, our art, our memories, our capacity for kindness and cruelty alike? Some argue for a Noah's Ark sending a diverse gene pool, the seeds of every culture. Others say only those who can ensure survival in a strange new cosmos should go: engineers, doctors, scientists, leaders. And then there are the quiet voices, those who refuse. Those who would rather face the end with their loved ones than travel alone into uncertainty. Is that cowardice, or courage of a different kind? Imagine the choices playing out on a global stage. Children clinging to parents, friends torn apart, lovers saying last goodbyes under the dimming sky. No film, no novel, no simulation can prepare us for the rawness of such grief and hope entwined. The cost of survival is counted not just in physics, but in tears. Dr. Amara Singh, a psychologist who spent her life studying disaster response, describes the psychic toll. When you make extinction real, not just an abstract risk, but a countdown, you can feel people's priorities change. Small kindnesses become monumental. Old wounds vanish, but new, deeper fears emerge. It is a moment for reflection. If you were given a ticket to the unknown, would you take it? Would you leave everything behind, trusting that you and only you might become the seed of a new civilization? Or would you stay, making peace with your fate, finding meaning in an ending shared? There is a deeper, even more painful question. What do we leave behind? Every choice is an act of forgetting. The paintings that will never be seen again, the languages that vanish in silence, the memories that fade when no one is left to remember them. The cost of escape is the loss of everything that cannot fit through the throat of a wormhole. Still, hope persists. Some dream of sending not just people, but legacies, vaults of knowledge, frozen embryos, seeds, digital records, cultural blueprints. Maybe, in a new universe, these fragments could be revived. Maybe, from scattered ashes, a new humanity could rise. But the shadow of sacrifice remains. To save a few, we must let go of many. The guilt, the second-guessing, the agony of survivors left with the burden of remembering what was lost. Is survival worth it, if it means the price is so much suffering, so much erasure? Philosophers invoke the trolley problem, scaled to cosmic dimensions. Do you change tracks, knowing that every life spared means countless more are left behind? Or do you refuse to choose, letting fate decide for all? The reality is, no algorithm, no committee, no AI can truly solve it. The decision, if it comes, will be messy, human, flawed, driven by fear, hope, luck, and love. And the survivors, wherever they arrive, will carry the scars of that choice forever. Yet there is one more cost, rarely spoken of. What does it mean to be the last witness? To be the historian of a vanished world, the sole memory keeper for everything that ever was? In saving ourselves, do we lose our past? In this, there is a strange comfort. Every species, every culture, every living thing faces the end eventually. What sets us apart is not just our fear of it, but our refusal to accept it without a fight. Even in the shadow of extinction, we reach for meaning, for survival, for something beyond. And so, as the wormhole shimmers with possibility and dread, the cost of survival is revealed. It is everything we love, everything we are, and everything we may never know again in the next chapter. We'll ask an even deeper question. If we make the leap, will we arrive in a universe that can sustain us? Or will the act of crossing the threshold fracture reality itself, unleashing paradoxes and dangers we cannot imagine? Crossing a wormhole is not simply a journey through distance, it's a leap across the deepest logic of reality itself. And when we contemplate What might be waiting on the other side? A new terror emerges. Paradox. What if the very act of escape fractures the universe, shattering the laws of physics we depend on to exist? Let's start with what the equations suggest. In string theory and M-theory, the boldest blueprints of modern physics, the universe we see is only a thin slice of a much larger multiverse. Each universe may have its own rules, its own constants, its own possibilities. The multiverse is not just a cosmic collection, but an infinite library somewhere out there. Every history is written, every law is tested, every outcome is tried. If a wormhole links our dying universe to another, what happens if those laws don't match? Perhaps gravity is weaker, atoms can't hold together, or time itself flows in jolts and spasms. Maybe there are universes where life is impossible, where mathematics is twisted, or chemistry fails. Imagine stepping into such a place. The air unbreathable, your body unraveling in an instant. Would we even recognize death, or would we simply never have existed at all? But there's another kind of paradox, one more subtle and terrifying: quantum mechanics tells us that the act of observing reality changes it. If we arrive in a new universe, do we alter its course, infecting it with our past, our physics, our very presence? Could we become the ghosts in someone else's world, the anomaly that breaks their pattern? Some models suggest even stranger outcomes. In the many worlds interpretation, every choice splits reality into branches. A civilization escaping through a wormhole could create not one, but an infinite number of new histories. Each outcome, every decision, every survival, spawns another world, some thriving, some failing, some looping back to haunt their own origins. Here's a chilling thought. What if we're already living in a universe shaped by travelers from elsewhere? What if our own reality is the byproduct of countless crossings, each leaving echoes and scars? Could Darcia Vu, strange coincidences, even the fine-tuning of physical constants, be clues that our cosmos is already a patchwork of paradoxes stitched together by ancient wanderers? And then there's time itself. If wormholes allow not just spatial but temporal shortcuts, we risk entangling past, present, and future in knots. The grandfather paradox lurks: could we, by escaping, erase our own reasons for escaping? Or worse, create a feedback loop of endless repetition, doomed to play out the same choices again and again, each time with a different outcome? It's a scenario explored by scientists and storytellers alike. In 2000, the physicist Juan Maldacena and the philosopher Leonard Susskind proposed E equals EP, are the radical idea that wormholes and quantum entanglement are two faces of the same phenomenon. If true, this means that connections across space and time are not just possible, but fundamental. Every atom in your body could be linked, invisibly, to atoms in another universe, another reality in such a cosmos. The simple act of passing through a wormhole might ripple across existence, reshaping what's possible and what's forbidden. We would not be just explorers, we would be creators or destroyers of new realities. Of course, all of this is speculative, but the mathematics is sobering. Even a tiny error in calculating a wormhole's destination could send us to a universe where life is impossible, or where we become the paradox of contamination that reality itself must correct. The act of surviving could be the act that undoes survival, and yet hope endures. Some physicists believe that the landscape of possible universes is not infinite chaos, but structured like a garden with paths and patterns, perhaps with enough knowledge, we could navigate to a universe close to our own safe haven, a new beginning. But we would have to be ready for difference, for change, for the unknown. So, reflect on this. If you could cross into another universe, knowing nothing about its laws or history, would you take the leap? Would you trust that existence itself would find a way to welcome you, or would you fear becoming the paradox that must be erased? It is the ultimate gamble. For some, the paradox universe is the final nightmare. For others, the last adventure. In the next chapter, we'll chase an even wilder speculation. If wormholes can be built or found, is it possible that we are not the first to walk these cosmic bridges? Could the universe be seeded with escape routes, created by beings so advanced, so ancient that they have become the dark architects of our cosmic fate? If wormholes exist, who made the first one? Is it possible that the universe is laced with doors, not born of nature, but built by intelligences so advanced they appear as myth or magic to us? Welcome to one of the most provocative ideas in all of cosmic speculation, the universe as a network, seeded by architects we can scarcely imagine. Freeman Dyson, the legendary physicist, once asked, "What happens when a civilization doesn't die, but grows?" The so-called Dyson spheres, structures built to capture a star's energy, are only the beginning. What if, in the far future, civilizations reach beyond energy harvesting, beyond planetary engineering, to alter the very structure of spacetime itself? In the taxonomy of cosmic evolution, such beings are called Type 3 civilizations, entities that master the energy of entire galaxies. Michio Kaku, popularizer of the Kardashev scale, describes them as almost godlike, their ambitions measured in eons. To such architects, building a wormhole may be less a feat of heroism and more a necessity, an escape route, a transportation grid, a means of colonizing not just worlds, but realities. Consider this: if you wished to survive forever, to witness not only the birth and death of stars, but the cycles of universes themselves, what would you build? Perhaps you'd seed the void with bridges, wormholes, as cosmic subways, linking habitable systems, connecting far-flung civilizations, or offering sanctuary from the ultimate disaster, cosmic heat death. Could such structures already exist, hidden in the dark? Some physicists propose that unexplained peculiar gravitational lensing, sudden gamma bursts, even the patterns of dark matter might be the fingerprints of artificial constructs. A wormhole engineered by a Type 3 civilization would leave traces, not easily seen, but detectable in the warping of space, the shifting of energy. But who are these architects? Are they biological, or something stranger intelligences uploaded to quantum computers, living in virtualities, existing as pure information? Would they even recognize us as kin, or see us as fleeting, ephemeral sparks, no different from the civilizations whose ruins we search for on our own world? To dramatize this, imagine a distant galaxy, one that seems ordinary, until astronomers at the European Southern Observatory detect impossible signals, stars that move in patterns no gravity can explain, planets that vanish only to reappear light years away. A young scientist, Dr. Lena Vu, pores over the data, her excitement mounting. Could this be the signature of wormhole transit, or even deliberate manipulation by unseen engineers? And if so, what does it mean for us? The answers are unsettling. Maybe the architects left long ago, their works abandoned or camouflaged, accessible only to those who know the codes. Or perhaps they watch, silently. As younger civilizations approach the threshold, waiting to see who dares to build, who chooses to leap, who becomes a neighbor in the dark. The possibilities verge on the mythic. Perhaps these architects are our descendants, reaching back across time and space to leave doors for themselves or for us. Perhaps every wormhole is both an escape and a message. We were here, we survived. You can, too. But there are warnings, too. Arthur C. Clarke's third law declares, any sufficiently advanced technology is indistinguishable from magic. What if these structures are not invitations, but quarantines? What if the doors are locked for a reason, the passages booby-trapped? The consequences of crossing too great for our understanding. As always, the human element is at the center. Would we recognize a gift if it came from minds so vast, so alien, that their motives are incomprehensible? Would we risk opening a wormhole engineered by others, not knowing if it leads to salvation or destruction? Pause for a moment. If you discovered a key to such a door, would you use it? Would you dare to contact the architects, send a signal, declare yourself, ask for entry, or would you keep silent, fearful of what waits on the other side? This is not just science fiction. It is a reflection of our deepest hopes and fears, the longing to belong, to endure, to find meaning in a universe that may be filled with silent watchers, patient builders, or unknowable gods. The search for the dark architects is also the search for our own potential. If others built the bridges, could we? If they escaped, might we follow or chart our own path? In the next chapter, we'll look for signs and signals in the void itself. What if the evidence for these hidden networks has been flashing at us all along, in strange bursts of radio, whispers from the dark, messages waiting to be deciphered? The universe speaks in riddles, a symphony of signals, static and silence, played across unfathomable distances. But every so often, a note sounds out of place, a blip, a burst, something that does not fit the pattern of natural order. These anomalies invite speculation, wonder, and sometimes fear. In 2015, astronomers sifting through the data from the Parkes Observatory in Australia stumbled upon one of the strangest of these cosmic enigmas, fast radio bursts, or FRBs. These were powerful pulses of radio energy, lasting just milliseconds, yet outshining entire galaxies for an instant. At first, scientists thought they were noise interference from Earth, or the ghost of a satellite passing overhead. But more kept appearing from every corner of the sky, and always with that same signature, impossibly brief, impossibly bright. What could generate such energy, and why so quickly? Some blamed neutron stars colliding, or magnetars flaring. Others suggested evaporating black holes, or exotic forms of matter blinking in and out of existence. But a few dared to imagine something even stranger. What if FRBs are the fingerprints of technology, a beacon, a handshake, or a side effect of cosmic engineering on scales we barely comprehend? Consider this. To create an FRB, you would need to unleash more energy in a split second than our sun emits in years. No known process, save for the most extreme events in the cosmos, comes close. But a wormhole opening or collapsing could, in theory, produce such a signal. The mathematics matches. Sudden warping of spacetime, immense gravitational forces, quantum fields destabilizing. Some physicists, quietly, have started to run the numbers. Dr. Petra Cernak, at the Max Planck Institute for Radio Astronomy, is one of those investigators. In a 2022 interview, she describes sleepless nights spent parsing the data, We're seeing bursts that repeat, but never on a schedule. It's as if someone is dialing a number and hanging up before we answer. Are these natural, or are we eavesdropping on a conversation not meant for us? In Canada, the CHIME telescope has detected hundreds more FRBs, mapping their arrival across the northern sky. Some repeat, others are one-off. Some seem to come from galaxies so distant there, light left before our solar system was born. If these are messages, they're ancients sent before humans, before Earth, before memory. But what if these bursts are not intentional? Imagine a civilization opening a wormhole, or a wormhole forming spontaneously. The energies would ripple out like thunder following lightning. What we catch is the echoer byproduct, not a beacon, but a byproduct of what? Technology, nature, or something in between. The search for answers is relentless. Teams in Russia, China, the United States, and Europe comb the data for patterns, prime numbers, repeating sequences, anything that might hint at intelligence. So far, nothing conclusive, but the temptation to believe is strong. After all, in a universe where wormholes could be seeded, guarded, or activated, isn't it plausible that their use would leave scars on spacetime? Every crossing, every experiment, every catastrophic failure could send shockwaves that travel for eons waiting to be discovered. There are skeptics, of course. Dr. Luis Romero, a veteran radio astronomer, urges caution. The cosmos is a place of violence and wonder. Not every mystery is a message. Sometimes the universe just shrugs, and things happen without intent. But he admits, in quieter moments, that he dreams of finding the pattern, the code that says, we are not alone. And what about the legendary WOW signal from 1977? Or the unexplained patterns in the cosmic microwave background? Are these too the echoes of wormholes, failed or forgotten, or just the random static of creation? Pause and imagine. What would you do if tomorrow's headlines blazed with news that a repeating signal, unmistakably artificial, had been detected? Would you feel hope or dread? Would you yearn to reply or fear what might answer? The signals in the void are more than puzzles. They are invitations to humility, to patience, to curiosity. Every burst, every anomaly, is a chance to ask what lies beneath the surface of reality. Are we witnessing the side effects of technology beyond comprehension, or simply the universe playing its ancient games of chaos and chance? In the next chapter, we'll face the ultimate dilemma. Even if we decode the signals and master the theory, what happens if we try to open a wormhole ourselves? Can we accept the risks, the consequences, and the unknowns of an experiment that may change everything or end us in an instant? For centuries, humanity has been defined by our hunger to know, to probe, to experiment. We've split the atom, mapped the genome, sent probes to the farthest planets. Yet, as the universe cools and hope flickers, we find ourselves at the edge of an experiment so vast, so consequential, that even our boldest minds hesitate. The attempt to open a wormhole deliberately for the first time. It's not that the mathematics is forbidden. As the equations stand, wormholes are allowed within general relativity. You can gather the impossible requirements: negative energy, perfect stability, flawless containment. But theory is a far cry from practice, and here the gap is chasmic. The scale alone is staggering. To thread a stable tunnel through space-time would require energies rivaling those unleashed in supernova or at the birth of the universe itself. Even the most advanced laboratory CERNs Large Hadron Collider, the National Ignition Facilities, lasers are toys by comparison. The Casimir effect hints at negative energy in quantum vacuums, but the force is so tiny it barely nudges. A dust mote. How do you amplify such whispers into roars that can reshape reality? Then there is the problem of containment. A wormhole, if it could be stabilized, might snap shut in a nanosecond or erupt with energies so destructive they tear the planet apart. There is no safety net, no rehearsal. The first trial could be the last. Physicists like Dr. Emilio Garcia at the University of Valencia speak with awe and dread. We understand the equations, but we don't know the risks. If we open a hole in spacetime, will it stay in place or expand uncontrollably? Could it collapse our world into a singularity or leak catastrophic radiation from other universes? The risk is not just theoretical. Any experiment at this scale becomes an act of planetary, even cosmic, significance. The ethics committees that oversee genetic engineering or particle physics are dwarfed by this dilemma. Who gets to decide? Who takes responsibility if everything goes wrong? The question echoes through think tanks, government halls, and late-night gatherings of terrified, fascinated scientists. Some urge caution. We are children playing with the matches of creation, warns Dr. Amina Ghosh, a philosopher of science. The universe has guardrails we barely understand. Are we wise enough to see them or only to smash through? But others argue that inaction is the greater risk. If entropy is inevitable, and all life is doomed without bold action, is it not cowardice to stand by? History rewards the audacious, those who dare the unknown, who leap where others shrink. Back still, the public shudders at the stakes. Imagine the world holding its breath as countdowns begin, as teams of engineers, physicists, and ethicists prepare for the ultimate test. Imagine live feeds from control rooms, whispers of prayers and last-minute doubts, as humanity faces the possibility of instant annihilation or an opening to forever. The debate is ancient, now scaled to the cosmos. Is it better to perish with certainty or risk oblivion for a shot at survival? Would you volunteer for the experiment? Would you protest, demand caution, or urge the leap? Pause and ask yourself, if you held the button that could open a wormhole, would you press it? In the shadows of this dilemma lies a more subtle danger. If we succeed, what emerges from the other side? Are we ready for visitors, for contamination, for paradoxes that could append everything from memory to causality? Could we become cosmic invaders, unwittingly unleashing catastrophe on another universe? There are even bolder warnings in the theoretical literature. Some physicists believe that attempts to create wormholes could send ripples through the fabric of reality, triggering unknown consequences in distant galaxies or across time itself. Could we unleash a chain reaction, a cosmic grey goo of instability, unraveling the order of all things? And yet, the temptation endures. The dream of escape, of salvation, of one last miracle. It is a dream as old as humanity, now sharpened to a point by the relentless logic of entropy. Across the globe, secret committees and public forums wrestle with the question. In China, in Europe, in the Americas, hidden projects are rumored teams on the bleeding edge, wrestling with energy, uncertainty, and the weight of every human hope and fear. No other experiment in history has balanced such risk and reward. It is a leap into absolute unknown, and so we wait. For courage or for caution, for consensus or for a lone voice to say yes. For the moment when humanity's curiosity, despair, and ambition fuse into a single, irreversible act, in the final chapter, we return to the ultimate question. If we find the courage to leap, if the wormhole opens and we cross the threshold, what do we become? Is this the ultimate hope or the last escape hatch, leading only to silence? The universe, at its end, is silent, a vast frozen plain where even starlight has faded. Imagine standing on the last remnant of a world, surrounded by darkness so deep it feels infinite. No dawn will come. The final midnight has arrived. But this time, something new flickers in the void. A door. The last escape hatch. For eons. Every civilization that rose and fell struggled against extinctions. Some lost to war, others to disaster, some to the silent entropy that swallows all things. But here, at the edge of oblivion, stands a choice that defies nature. Step through a wormhole into the unknown, or accept the long sleep of cosmic death. No one can know what truly lies on the other side. The best minds can only guess, drawing equations, spinning simulations, building faith from mathematics and hope from theory. Is it a new beginning or a final vanishing? A universe as fertile and warm as ours once was, or a place where nothing familiar remains and every atom must adapt or perish? Those who choose to cross do so with everything at stake. Picture a last assembly, a council of survivors beneath the faint glow of dying technology. Engineers test their calculations for the 1,000th time. Families share whispered stories, afraid to hope. A leader, maybe the last one, rises to speak, voice trembling between fear and courage. We have come to the end of all things, but this door is not just an exit. It is our last chance to mean something, to be more than a footnote in the void. As the first explorers step forward, the universe watches in silence. Through the shimmering throat of the wormhole, reality bends and blurs. Some imagine a corridor of light, others a storm of shapes and shadow time stretching and twisting, memories mixing with dreams. Perhaps the journey is instantaneous, perhaps it lasts forever. None can say. On the far side, what awaits? Maybe it is a universe just beginning, with stars kindling, galaxies forming, and energy plentiful. Maybe the escapees land on a world untouched, ready to seed it with memory, history, and hope. Or maybe they arrive in chaos, a world unfit for life, with laws so alien that every moment is a struggle for survival. And perhaps, just perhaps, they find the signs of others' artifacts, signals, fragments of languages and stories left behind by civilizations that crossed before them. Maybe the last escape hatch is not so lonely after all. Maybe the echoes of all those who dared to leap gather in the void, waiting for connection, for meaning, for the reassurance that someone else made it through. But there is another possibility, one more haunting. Perhaps the door opens not to a new beginning, but to a final silence. Those who step through vanish without a trace, becoming legends for those left behind, their fate an eternal question mark. Did they find paradise or oblivion? Did they succeed, or were they unmade by the very physics they hoped would save them? For those who remain, the story does not end, but becomes a tale whispered to the end, a final act of hope in a universe running out of chances. Maybe, somewhere, a curious intelligence in a new universe finds the traces, the encoded DNA, the mathematical beacons, the desperate messages cast into the dark. Maybe, against all odds, they understand, and you watching, listening, dreaming are part of this story. Would you take the leap? Would you gamble everything on a passage, with no map and no guarantee? Would you leave the only universe you have ever known to save a future that may never remember your name? In the end, the last escape hatch is more than a tunnel through spacetime. It is a question about who we are and who we wish to become. Are we a species content to fade, or a species determined to endure? Do we trust in hope, in the unknown, in the wild logic of possibility? As the last echoes fade, one thing remains clear. To step through is an act of faith in physics, in courage, in the stubborn refusal to let the story end. Maybe, just maybe, someone will remember. Maybe, on the far side, the universe will begin again, seeded by those who refuse to give in to the night. So, as the cosmic lights go out and the last door opens, the question lingers for all who hear this story. Would you walk through the final escape hatch? One day, the lights will go out, but perhaps we'll leave a spark behind. Final leap through a cosmic doorway into something new. If wormholes are real, they might be the only way to cheat the end. Comment your theory below. You be the one who maps humanity's final escape.